Now when we are looking into grooved weld, this is the first type of weld. There are further types of weld in grooves. So groove is not only a single type according to the thickness. If you are two material, see this is a single material and it has to be connected by another one. Always groove weld will be connected in a single plane. What do you mean by single plane is, if you are having any connection like this, it is a double plane. This is one and another. So always groove weld will be in a single plane, that is the connecting member will also parallel. Okay. If the thickness is less than 12 mm, one plate is there and it is having 8 mm and this plate is 10 mm, then you can make a square V or double V type bolt. This kind of groove weld you can make it. If you have more than 12 and up to 40 mm plate thickness is there, you can go for single bevel or bevel type. So this we will discuss in detail. Generally the groove welds are used for butt joints, and before going into groove weld you should know the components of a groove weld. Since you are connecting with the two members, if you are making any V joint or bevel joint, you have to have a root radius. So this part is called root. So when you are connecting two members, you just observe here, these are the terminology which they will be giving in problem, or when you are providing any welding, if you are working, you should know this terminology to communicate well. Okay. So the root will always be a rectangle section, and after that either you can make U joint or you can make J like that. So number of joint can be made. Here can you see the J joint? This is like the shape J, isn't it? So you can find the J type here. This is single J. What do you mean by double J is, the J will be there at the half of the section. So the remaining half will be the mirror. So this is J joint. What do you mean by U is, the complete U will be found here. So when you want to connect and the small distance is there, this terminology called root opening, and the weld size which has to be measured from the top to the bottom. So the overall thickness is the weld thickness, and this portion is called the root face, and the remaining portion penetration. When we are speaking into this is the face of the weld and this is the back side of the weld. So you have two faces. Okay, and this is face reinforcement. So whatever thickness you have, this is the material, and after the thickness of the material, up to how much height is projected, which is called the face reinforcement. Okay. So with this terminology, in the problem they might give the word effective throat. So what do you mean by effective throat is size of weld. So whenever they are giving in the problem effective throat of the weld, they can give it as 6 mm or 7 mm. What do you mean by effective throat is, see this is the effective throat. So can you see this distance? Whatever distance of the weld you have, so this is known as size of the weld or effective throat for the groove welding. Okay, the groove can have a slope up to 30 degree to 60 degree. So whatever slope you have, here there is J joint, and in case of V joint you will be having some slope. So this slope will be generally 30 degree to 60 degree, and the edge preparation is necessary. What do you mean by edge preparation is, see if you are having two plates, the plates cannot have irregular sides. So the sides are very sharp here. So you can see a sharp edge. So always when you are making a groove weld, you have to make your surface into a sharp edges. So it cannot be uneven or irregular. So what are the types of groove joint available? Square type, V type. So V can be a single V. If you are making double V, you will be having at the top as well as at the bottom. And this is single bevel. What do you mean by single bevel is, See, one joint will be straight and another joint will be having this cut. The additional plate what you are joining will be having this cut. So this is known as bevel, and if you have at both at top and bottom, this is called double bevel. This is called U shape. If you have both top and bottom, you will be having double U. And you can see by this shape, you can see a J type, and this is single J, this is a double J. Okay. The weld metal is very expensive when comparing to the base metal. Why you cannot provide more thickness of welding is the material which you are using for welding, which will be very much costly. Say for example, if you need effective thickness of 8 mm, 8 mm of weld is required. So can you provide 10 mm of weld? Yes, you can provide, it will be safety, but what it will extend is, it will take down your expense. So you have to provide optimum thickness only. If you are more utilizing your weld material, it becomes more expensive and requires time, power, everything. The optimum thickness you have to choose and you have to provide that. Why? Because the weld metal is expensive when comparing to the base metal. Steel rate will be around 70 rupees or 80 rupees. So you can have plates round, square like that. But when you are connecting the metal by using this welding material, it will be costlier, and this is what I have highlighted. The double bevel or double V for the plate thickness less than 12 mm. So up to here, so this is single bevel and this is double bevel. So up to here you can use for 12 mm thick plates. You can use 12 to 40 mm for what kind of groove is J and U type. So this is single J and single U. Single J and single U. This you can use when you have the plate thickness of what? 12 mm to 40 mm plate. If you are having higher thickness of the plate, more than 40 mm, what you have to use? Double U or double J joint. So these are the different kinds of groove weld which will be used. Groove welds will always transmit the full load, and the material will be having same strength as the member and joint. So this is what I said in the last class. Whenever you are using plate of 410 grade, you should be make sure that whatever welding material you are using is more than the 410 grade. Okay. Next type of joint is fillet weld. So already last class I have discussed what do you mean by fillet weld is, see, you are having two planes. One is at x axis and another one is at y axis. You can see at the corner they have connected by the fillet weld. So these are the different types of fillet weld. This is not only a single type, you will be having lapped angle on plate. So what do you mean by angle shape? Angle is L. When they say it has angle section, it is L. What do you mean by beam shape? What is beam? I section. If you are not knowing, take it as note. In the problem, they will only give that 2 IS angle section is being used, and it is for a size thickness of this. So if you are not knowing what is angle section, it is very difficult. Indian standard angle. A stands for angle, and if they say like that, they are using L shape cross section for the section. And if they are saying ISMB, Indian standard mild beam. What do you mean by beam is I section. They are using I section. So angle section you know, I section you know. What do you mean by channel section? Channel section is C. When you have a cross section of C, it is known as channel section. So you should know the terminology, and here they have given lapped angles on the plate. So they have provided an angle section here, that is L section, and they have welded with the splice plate. This part is known as the splice plate. Okay. So this is what kind of section? This is a T section, isn't it? This cross section is similar like T. How they have created this section is, they have only jointed two rectangular plates. So this is a plate section, and another plate they have connected. By connecting two plates, they have made a T section. So you can make I section also. You can add additional plate at top you can make I section. In case of welded elements, you can keep on add or build up your sections, and this is called slotted connection. What do you mean by slot is, if you need more effective length, designing your weld length might be around 600 mm. So what will happen? You need to provide 600 mm length, in the sense 600 mm is how many feet? 600 mm is how many feet? 2 feet, isn't it? So if you need to provide 2 feet of connection, is it possible practically? Is it possible? 2 feet. See, from the face of the wall, you will be extending 2 feet and your splice plate will be like this. Is it possible? So everybody will provide a small spacing for connection. So if you need more length, what they will do? They will provide this kind of slot. See, this you would have seen in crowded areas. If you are going through a queue, what they will make is, the length will be too high if you are standing in a single line. So what they will do? So they will make U-turns. In a single area, they will make all U-turns and more number of people can be occupied. Yes or no? The same way the weld is also operating. If you need more length, what you can do is you can provide this kind of slot. So by this slot you will be covering more area, the strength will increase. So how much ever you are projecting the weld length, that much strength you are going to get. Okay. Now this is a bracket and you can see the bracket is connected in this manner, and you can see angle section which is being provided at the top. Also the column base plate, when you are connecting a column, see at the bottom of the column you might have the base plate. How to connect at the base plate is, you have to weld all the connection. So what is the shape of the weld? Can you see a C shape? Can you see a C shape here? When you are connecting column base plate, what shape you have to use generally? C shape of weld you have to use. So you cannot connect only this plane. So what will happen? If you are only connecting this plane at both the sides, what will happen? Imagine and tell me. You are only connecting at two sides of the I section. This is a column, only you are welding at two sides. If force is acting at this portion, what will happen? You don't have resistance, yes or no? You don't have welding that area, it doesn't have resistance. So that the welding should always be at both the axes. Whatever the angle of the force it might be, it might either might be in x axis or y axis, your weld should be having at both the direction. So that is why you can see weld at this axis as well as this axis also. Okay. So you should know the types of connection and you should know the types of shape. And this is built up connection. You can see 3 plates are used, 1, 2 and 3. So these 3 plates, if you want to connect, you have to provide weld at the corners of the connection. So with this kind of application, you can make the fillet joint. Okay, the fillet joints are economy, easy to fabrication. In case of groove, what do you have to do? In case of groove weld, what do you have to do? We have given in last class. This is a grooved joint. If you want to make groove, so what do you have to make? You have to cut the member and then make the weld. Then only you will be having finished surface. But in case of fillet weld, you are not cutting any members. You are just placing and providing a weld. So what happens? It is two work what you have to do. If you are providing a groove weld, first work what you have to do is cut the plates. Cut J joint, cut U joint like that. But in case of fillet weld, you don't have to cut anything. Just if you have 2 plates, merge that plate and just weld it. So it is very easy for fabrication and economy also. It is highly adaptable, whatever might be the condition, so that the fillet weld are used for 80% of the steel structure. Whenever you see, all steel structure will be having fillet weld only. Okay. Then unlike groove weld, it requires less precision of filling up. So no need of precision. You can just weld for the throat thickness. Whatever throat thickness they have given, you can just provide for that. Do not require any edge preparation. So this is what I said. if you need this kind of joint, so this is a bevel and you need edge preparation, that is you cannot have uneven edges when you are providing for groove joint. But in case of fillet joint, yes, no need of preparation of edges, it might be irregular, so you can provide the fillet weld. Always the fillet weld are assumed to fail in shear. And last two types are slot and plug weld. So this is what the next two type. This is called slot and this is called plug weld. So slot and plug welds are not used for extensively in steel construction. Wherever you don't have any length, so at these places you can have a slot. Instead of, see, there might be some cases, a member might be bolted connection, you might already have holes on the plate, both the plate as well as the member. So for those area you already have the holes, how you can weld? You can fill that. When it becomes impossible to use fillet weld, then you can use the plug weld, and they also assume to fail in shear. You can see one member is connected at the bottom and another member will be having the same amount of holes here and it will be welded. So this is similar to the design of fillet weld. Whatever procedure you are using for fillet weld is same for slot or plug weld. Before going into design, you should know what are the defects of weld. We have 7 possibilities of defect. So what are the defect is, when you are connecting two members, this is member 1 and 2. If you are not providing the fusion at the edges, you can see this first slide, the fusion is not provided properly. So this is member 1 and member 2. At the bottom side it has been connected well, and at the top side if you have incomplete fusion, what happens? This is a first weld defect. And inadequate joint penetration. So if you are having the joint, see what kind of joint is this? V joint. So if you are connecting the V joint, see, you should provide the root, yes or no? I have already mentioned that you should have a root, then you should have the shape. So every joint has some root. So if the shape is not provided properly, that is inadequate joint preparation, then it causes failure. So when you are making the groove, the J joint should be like J. So it should not be some other way. So why? Because it creates the weld defect. And also porosity of the weld. If you are welding at the particular area, it should have completely filled with the weld material. If you are having any pores inside the weld, it is the weld defect. Okay. Then gas pocket. What do you mean by gas pocket is, there may be openings in the holes. So you can see the weld here and there might be some air holes. So there might be some pockets of unfilled area. This creates the weld defect. And undercut is, if you are making the V joint here, if one angle is 30 degree and another angle is 20 degree, you should not make that. This is the reason for what failure? Undercut failure. Undercut failure is, if you need 30 degree, you should provide both the sides as 30 degree. Inclusion of slag. See, if any foreign material, that is whenever you are welding, if any leaves, thread, foreign particles, if it is merges with the weld, then what happens? The strength of the weld get reduced. So the weld should completely filled with the weld material only. No foreign object should be there. There should not be any dust due to sand. See, whenever you are working in any site, you will be having dust. Whenever you are welding, you should make sure that the working place is free from any foreign object. So it should be closed. More sand particles should not be there. So when you are making a joint and if you are having any longitudinal cracks, so this is the weld defect. These defects you should make sure that when you are welding, you should eliminate all these defects. What are the types of joint? V joint, J, U, bevel. So these are the types of joint. When you are selecting a good type of joint, then sound welding can be achieved. Yes. Next one, its preparation and its filling up. So how you prepare the surface and how you fill up governs the sound of the weld and root opening. I have already said that whatever joint you are making, you should have the root. So by root opening, the quality of the weld is being achieved. And choice of electrode. So electrode is the material which you will be catching at one side and you will be making the weld. So that electrode should be of choice of yours. So whatever the electrode choice you are making, which decides the quality of your welding. When you are making a weld at the bottom, it is very easy. But when you want to make a weld at the top or at inclined area, it is very tough. The workers cannot work for too long and the quality will not be that much good. So when you have a angle of sight, below your angle of sight, it is very easy to weld. You can weld it horizontally, you can weld it flat or vertical, you can do it. But above your eye line, if you are having any angles, it is very difficult. So that is why positioning of electrode. So how you make your weld. So that is why shop weld have higher safety. When you are making in a site, you will be not having that much time and the angle might be whatever might be the angle. So you might not get optimum work. So when you are working in shop, all the things will be there below your line of sight. So it is very much easy and quality also you can get it. These are the different type of joint. What are they? Butt joint, corner joint. Always butt joint will be connecting the two members. Corner joint, T. So by this shape you can understand this is a T joint. You can provide at the corners only. And lap joint at the end of the member. If two plates are used, at the end you have to provide the weld, and edge joint is at the edge of two members you will be connecting this. So this is the combination of horizontal edge joint. If you are saying, then this joint will be like this. In the problem they will be giving a vertical lap joint. So they will just give the terminology that vertical lap joint. You should know to draw the picture. What is vertical lap? So this is your vertical lap. This is lap joint and this is vertical. So how your material should be there? Two plates are connected and it is welded at one area. So you should know all the combinations. If in problem they are giving vertical T joint, so you should know to draw this one. This is vertical and this is T. So you are welding at the vertical mode. So these are effective areas of weld. How to find effective areas? You know that when you are connecting two plates. So this plate is having a thickness of T1 and next plate you will be having thickness of T2. Double bevel. So with this joint itself you should know to mention. So what kind of joint is this? Double V. You can see the V shape here. Now you have the root thickness here and note that T. What is T is? Effective thickness of the weld is 5/8 of thickness. So whenever you have a larger plate and smaller plate, what plate you will be taking always? Smaller plate thickness you have to take and design. How to find the area is effective throat dimension, which is thickness into multiplied by the effective length of weld. How to find the area? See, just you cannot find breadth into depth. In case of welding, what is the formula for finding area? Effective thickness into length of weld. This is the formula for finding area in welded connection. Note here that even though your weld might be for a depth of D, see this is the depth of D which you have cut, but effective thickness is different. Next you have to understand this concept. When this welding is being provided here, this will be in a triangular cross section. Half the portion will be in vertical and half the portion will be in horizontal. So if you are taking this as the weld, the total weld which has been made, if this distance is A, that is 10 mm and this is 10 mm, how to find effective thickness is 0.707 A, where A is what? The size. So when you provide the length of 10 mm and 10 mm, what is the thickness you have to take? You should not take 10 mm what you should take? 0.7 of 10. This is the distance for the effective thickness. Whenever you are welding, you should not take the vertical or horizontal length. You should take the diagonal of this triangle. In case of fillet weld, so this is known as effective throat. Okay, when you are having different dimension, that is in length you have different dimension and in height you have another dimension. So how to find this thickness is, take this as A and B, you have to multiply A and B divided by root of A square plus B square. So this will be your effective thickness. Code book they have given us the effective throat thickness of fillet weld should not be less than 3 mm and it should not exceed 0.7 A. This is 11.3 for all the fusion of faces. So whatever the type of weld you are using, the average throat thickness and the angle required can be designed by using this table. And whenever you are designing, you can find the angle of your weld. See, it is just mentioned that V joint or J joint like that. What is the angle to make the constant K you are taking for each and every constant K? So you will be having the angle of fusion. So when you assume 0.6 of the K constant when in the design, you have to provide 101 degree to 106 degree like this. So how the angles are measured? So this is the angle, and if this is your slope, it is measured in terms of vertical. So from the vertical, what is the angle which is measured here? When designing, we shall discuss in detail. And in right side you have another table where they have given the size of weld required. So what is the plate you are using and what is the minimum thickness of the weld required. This assumption is common whenever you are taking the concrete structure also, you will be having the same thing, and the material in the welded connection are taken as homogeneous, isotropic and elastic. Welding is considered as fixed. The joint is very rigid, fixed in the sense rigid. So weld are always considered as rigid and therefore deformation are neglected. But in bolted connection they are not rigid. Bolted connections are hinged connection, they will be having deformation. Okay, only stresses due to external force are considered, no other forces are considered. That is residual stress, stress concentration and shape of the weld are neglected. Whatever shape you can provide, this is neglected, and stress concentration, this is there at bolted joint. Whenever you are designing bolted joint, you have stress concentration. But in case of weld, there is no effect due to stress concentration and residual stress. Now 18 mm thick plate is joined to 16 mm plate. You have two thickness of the plate, one is 18 mm and another one is 16 mm. So you have to take the minimum thickness, okay, by a 200 mm long effective butt weld. You have to connect that. Determine the strength if you are using double V butt joint or single V butt joint. You know that when you are connecting, you will be providing V groove. When you are providing this V, they are asking either single V is enough or you need 2V in order to take. So what will be the strength of the weld which is used? Assume the plate grade as 410 grade and shop welds are used. When you are designing the welded connection, take the IS 800 page number 78. Whatever the required information, you can get it from there. Double V butt joint. So this is your case 1. This is what I said earlier. Whenever you are taking the thickness of the thinner plate you have to take. Which is thinner here? 16 mm is thinner. So the throat thickness has to be taken from the thinner plate only. That is T equal to 16 mm, which you will be taking, and effective length of weld LW they have taken as 200 mm. This component is given. And what are the other given components? They have said that ultimate strength of plate FU. FU is what? Ultimate stress of the plate is 410 Newton per mm square, and since it is a shop weld, gamma M, that is material factor of safety, is taken as 1.25. See, only these two conditions they have given. These three conditions they are given in the problem, and if you say shop weld, it is given in partial safety factor for material. You have used that table already, yes or no? Safety factor for bolt, you have the table. You have to collect from that. Okay. How to find effective area? Length into throat thickness. What is the length? Effective length of weld. What is the effective length of weld here? 200 mm. Yes. The partial safety factor you can find in table 5. Here they have given for partial safety factor for shop fabrication as well as field fabrication. Okay. When you are using shop fabrication, what type of connection you are making? Weld is last point, you have shop fabrication as 1.25. When you are making field fabrication, you have to use 1.5. So here they have given as 1.25. That is why you are taking gamma MW as 1.25. Okay. Then do you have class 10.5.4? They have given the effective length or area of the weld. How to take that? So the effective length of fillet weld shall be taken as that length which is specified as size required throat thickness. So whatever throat thickness is required, you can take that and calculate the effective area of the weld. Okay. Can you find 10.5.7? Design stress in weld. There they have given the formula. How to find stress? See, what is the formula for finding stress? Load by area. So if you need force, you can cross multiply what? Stress into area. So this is the stress and this is the area. Fu is known as ultimate stress. So what is this? LW into T is area, isn't it? What is the formula for finding area? Length of weld into throat thickness. So this is the length. Length of weld is what? 200 mm. Throat thickness T equal to what? They have given the thickness of the member as 16 mm, and if you multiply these two, so you will be getting first two component. What is FU? FU is 410. What is gamma M? 1.25. So you multiply all the component. Butt weld, you can take the thickness as it is. Whatever thickness they have given, you can take as it is. But you are making fillet weld, then you have to find the effective throat thickness as TE. Okay, what is the answer for this? 6,05,987 Newton, which will be 605 kilonewton. Now, when you are using single V, butt weld is used. So, now take the next case. Now, since the penetration is not complete, how to find effective throat thickness? 5/8 of the thickness. What is 5/8 of 16? Which is 10 mm. Now, when you are using single V butt joint, the effective throat thickness will be 10 mm. Now you substitute the 10 mm in this case, you will be getting this answer. Length of weld is 200, thickness is 10, FU will be same 410 divided by root 3, gamma which will be 1.25, 3,78,742 Newton, which will be 378.7 kilonewton.